Scientific notation is what lesson 6 is about in chapter 1. So scientific notation, it says here at the top, is when a number is written as a product of a factor and an integer power of 10. The factor must be greater than or equal to 1 and less than 10. Here's what that means. All scientific notation is a first factor. Now factor indicates that we're going to be multiplying times a power of 10. All right, and then there's an exponent. This factor of 10 has to be greater than or equal to 1 and less than 10. So we need a number right here that's between 1 and 10 times 10 to an exponent. Now this exponent right here tells you the number of spaces. This is how I want you to think about it. The number of spaces. Come on, catch up with me here. I'm telling you what, this pen, I just don't know. The number of spaces the decimal moves. So the number of spaces decimal moves. Now, that'll become more clear to you whenever we do some examples here in just a minute. So the reason why we even use scientific notation is if you have a very, very large number, and let's say I'm going to multiply by that by something, it's going to be huge, probably not even going to fit on your calculator. So there is a way of taking very, very, very small numbers and very, very, very large numbers and writing them in a usable form. That's what this is. So if I have a number like 425 million, and if I have to write that as a number between 1 and 10, that decimal right now, any whole number, is at the end. So I have to move it somewhere. If I move it, let's say right here, that'd be 425,000. Not going to work. Even if I move it right here, that would be 425 point. That's 425. Still too big. Let's say I moved it all the way to the front, 0.425. That's not a number between 1 and 10. There's only one place to move it, and that would be right there. And make it 4.25. So 4.25 would be my factor that's between 1 and 10, times 10 to an exponent. Now, the exponent, I told you right here, is the number of spaces that the decimal moved. So I would move it 1, 2, 3, 4, 5, 6, 7, 8. It moved 8 times. This was a very large number. That's the reason why my exponent is positive, because we're going to have positive and negative exponents. So let's try a few examples right here. It says write each number in standard form. Now, standard form is just the normal type number that you would normally see. So we have standard form, and then we have scientific notation. You're going to have to go back and forth in this lesson between the two. So standard form is just a regular number. Scientific notation is a number between 1 and 10 times 10 to an exponent. So right now they're given to you in scientific notation, and you have to make it in standard form. So whenever we look at this, we've got 5.34 times 10 to the 4th. We said that this exponent right here tells you how many spaces the decimal moves. And because this is a positive number, we need to make this bigger. That's what I want you to associate. Positive exponents associate that with large numbers. If it happens to be a negative exponent, then in standard form, you're going to end up with a very small number. All right, so I want you to keep those kind of things straight. Maybe put that in your notes for you to refer back to later. This is a positive exponent. We need to make this a very large number. Well, if I move the decimal point this way, you're making a very teeny tiny decimal, so that's the wrong way. I need to move it to the right 4 times. 1, 2, 3, 4. Add zeros in my empty space. Sorry, I put the comma in the wrong one. 53,400. 53,400. This one, this time I've got a negative exponent. So negative exponents I should associate with very teeny tiny small numbers. So if I move this one to the right, I'm actually making this number bigger, and that's not what I want. Negative exponents, teeny tiny. Got to move them to the left. 1, 2, 3. and I'm going to add 2 zeros right there. 0.00327. 0.00327. Then you get a cute little teeny tiny decimal just like that. Oh, isn't she sweet? All right, that's what we got. So keep those kind of things straight and you will be good. So I want you to try these got it examples right here, A, B, and C. Remember that if it's a positive exponent, we will move it to the right. And if it is a negative exponent, because we need those cute little teeny tiny baby decimals, we have to move it to the left. All right, try those and come right back with me and we will talk about the answers. Okay, hopefully you're back by now and let's go over some examples. So 7.42 times 10 to the 5th, positive exponent, I move it to the right 5 times. Notice I am not adding 5 zeros. That is not what that means. 1, 2, 3, 4, 5. I actually only ended up adding 3 zeros. So those of you who mistakenly think that's how many zeros it is, that is not always true. 7, 4, 2, 0, 0, 0, 742,000. Negative exponent indicates a cute little baby decimal. 1, 2, 0.061. Positive 2 makes it bigger. 1, 2, 371.4. All right, so that is taking scientific notation and making them into standard form. Now let's practice a few going the other way. It says write each number in scientific notation. So it's asking you to take 3,725,000 and make it scientific notation. So remember, the decimal has to be a number between 1 and 10, the whole number up front. So this number right here has to be a number between 1 and 10. There's only one place anywhere in here that I could put that decimal to make it a number between 1 and 10. If I put it here, my number is now 37.25. That is not a number between 1 and 10. The only place to put it would be right here. So my decimal, 3.725. I have to take all the digits right up until I start getting to these zeros, and I can forget about those. So 3.725 times 10 to the, how many spaces did I move it? I moved it 1, 2, 3, 4, 5, 6. Now, is this a positive 6 or a negative 6? Well, it happens to be positive because this number right here was a large number. Therefore, we have a positive exponent. When you have a cute little teeny tiny one like this, 3.16 is my decimal, times 10 to the, how many spaces? 1, 2, 3, 4. Positive exponent or negative? Negative because it was a cute little teeny tiny one to begin with. All right, so I want you to keep that in your brain, keep it in your notes. If you have a negative exponent, you should associate that with what kind of decimal? Teeny tiny. And there's a, oh my, got a mind of its own. Come on, honey. Yeah, it really jumped up here. My apologies. Got a board that's, I don't even know what you want to call it. Keep going. One at a time. One at a time. Okay, starting to get a little ticked. All right, let's do this. Got it right here. D, E, and F. Before I throw something at this board. D, E, and F. Pause them and try them, please. All right, let's go. This is a very large number associated with a positive exponent. Has to go right here to the right of the first non-zero number. So my answer, 1.414, I do not need to put all the zeros, times 10 to the, this part's always standard, has to go there, 1.414 times 10 to the, I moved it 1, 2, 3, 4, 5, 6, 7. And it is a positive 7 because it started off as a very large number. This one has to go here to the right of the first non-zero number. 8.76 is my decimal. times 10 to the, and I would have to move this 1, 2, 3 places. And it is a negative decimal because it started off as a teeny tiny decimal. Same way with this one. Right at the first non-zero number, 1.14 times 10 to the, I only moved it one time, so it's a 1. Positive or negative? It would be negative. Why? Because it started off as a number less than 1, a teeny tiny decimal. All right, now let's see if it's going to behave itself. Okay. Let's talk about putting these things in order. When we put them in order, it gives you all of these. And we have to put these in order from smallest, sorry, this one wants greatest to big, try this again. Greatest to least, whenever you're talking about the amount of money spent. All right, let's look at these. Here's the first thing that I want you to do. I want you to group them by exponent. So let me see if I can do this with a highlighter here. So we've got, that's a 10 to the 7th, and that's a 10 to the 7th. So that group would go together. I've got, this is a 10 to the 6th, this is a 10 to the 6th. So whenever I talk about grouping these together, it's because exponents are what tells you the size of it. This number here out front doesn't really mean anything because this tells you how many spaces to move it. All right? So always go by the exponents. So if I want the biggest one first, that's going to be my biggest exponent. So it's my 10 to the 7th right here. My biggest exponent, once the exponents are the same, now I can look at these. All right? So my 1.06, 1.06, which happens to go with the UK. That's going to be the greatest amount. Then it's going to be my other 10 to the 7th, which would be Canada at 1.03. Next, I look at my 10 to the 6th. And if I want the greatest one, now I look at the numbers. My 7.15, which would be Mexico. And then I have my 1.83, which is India. Now again, if you're just looking at these, those numbers don't look like they're in order. We did not really look at those until we looked at the exponents. So make sure you're going by the exponents first. Go ahead and try G. All right, back with G. I need to look at my exponents. I've got 10 to the 5th right here and a 10 to the 5th right here. It says this time least to greatest. Make sure you are looking at your directions. The example before it said greatest to least. This one says least to greatest. Just depends, whatever they want. So if we want least to greatest, that would be my 10 to the 5ths. So since 10 to the 5ths are the same, now I can look at that one. So smallest, Boston. Next smallest, Metro DC. Now I can look at my 10 to the 6th. So if I look at my 10 to the 6th, those are bigger than both of the red ones here. But if I'm still going least to greatest, next I would have Las Vegas, and then I would have Los Angeles, because 1.3 is less than 2.2. Okay. Moving on, let's just go through a couple of examples here at the end, and then you should be good to go. Under guided practice. Under guided practice, just real quick, I've got 10 to the 5th, so I would move this 5 times to the right. Negative 4th, take this decimal and move it 4 times to the left. I've got this one in scientific notation. Has to go right here, 8.785 times 10 to the 3, 6, 9, positive 9th. This one I've got 5.524, move it 1 time, 5.24 times 10 to the negative 3rd because it started off less than 3. Good luck.